There's a brand new crater on the moon. The Artemis II astronauts have returned home safely. A new survey has just wrapped up its scan for dark energy, and supermassive black holes ready to merge. And in Space Bites Plus, astronomers find one of the oldest stars in the universe. All this and more in this week's Space Bites. The moon has seen some stuff. Now, if you look at the surface of the moon, you can see craters within craters within craters, and this constant pounding has happened over the course of billions of years. In fact, astronomers count craters to figure out when various events happened on the surface of the moon or Mars. You can see old craters, and then you can see where new craters are inside of old craters, and this allows you to figure out which geological formations came first. But the moon is still in this cosmic shooting gallery like the rest of us, and so there are still new craters that happen on the surface of the moon. But these are not usually very large craters. The previous record, before what I'm about to talk about, is 70 meters across. That is the size of the crater on the surface of the moon. Well, astronomers were looking through images taken by the Lunar Reconnaissance Orbiter, and they found a brand new crater. This one was probably caused in late spring 2024, and it measures 225 meters across, and it's 43 meters deep. The crater walls are so steep you could barely stand along the wall, and there are blocks of material ejected from this impact site that are tens of meters high. So this is a very significant impact on the surface of the moon. And researchers were able to see glass-like material at the bottom of the crater, essentially where the regolith liquefied after the impact, turned into kind of lava and eventually cooled like glass. It would be a great target to send a new mission to because it's a brand new crater and pretty much the largest crater that is formed in living memory. And it just reminds you that when we do have a permanent base on the moon, occasionally these kinds of objects can strike from the sky. Got a story about this from Mark Thompson. So we've been reporting on the Artemis II mission for several weeks now, and it's time to reach the thrilling conclusion. Part 3, the Artemis astronauts return. The 4-person crew of astronauts had spent 10 days going all the way out to the moon and then returning back to Earth, re-entering the Earth's atmosphere at high speed. They splashed down at 5:07 p.m. Pacific Daylight Time off the coast of San Diego. And what an incredible flight. I'm sure many of you were watching every single moment of this, and I was watching a lot of this. Some of the live views coming from the Orion capsule. They completed over 1.1 million kilometers in their round trip. They broke the record for the farthest that human beings have ever flown away from the Earth. They saw the far side of the moon. They saw Earth rise and Earth set. They saw a solar eclipse that lasted about an hour, allowing them to see micrometeorite flashes on the darkened portions of the moon. They were able to see the Milky Way with their own eyes and planets that were now visible because the light was blocked from the sun. And then, of course, one of the big concerns that we all had was what was the status of the heat shield? And I'm sure it's going to take us a few more weeks for us to find out exactly how the heat shield fared. But obviously, it did the trick. It got them back safely to Earth. And so now Artemis II is complete, and NASA is preparing for Artemis III. Now, originally Artemis III was going to be the mission where they went to the surface of the moon, and now Artemis III is going to be a dress rehearsal for the orbital maneuvers, the docking that needs to be done for them to be able to take crew to the surface of the moon. So we're going to see launch of the Space Launch System. It's going to dock with whichever lunar lander is ready to go at the time, whether it's the one from SpaceX or whether it's the one from Blue Origin. And then with Artemis IV, that's when they're going to go to the moon. And the hope, of course, is that we will see this human landing on the moon before the end of the decade, of course, before the Chinese are expected to do it in 2030. And we've got more information about this from Matt Williams. I've been talking quite a bit about all of the new discoveries that are being made about dark energy. This is thanks to several new surveys that have been built. Some are observatories on Earth, others have been launched into space. There's DES, the Dark Energy Survey. There's the Euclid mission. There's Rubin, and there's the upcoming Nancy Grace Roman telescope. But one other survey has just wrapped up its 5-year exploration of the cosmos. And this is DESI, the Dark Energy Spectroscopic Instrument. This is a very cool telescope. They have a collection of robotic fiber optic cables that are attached to the instruments as part of the telescope. The telescope moves to a new spot in the sky, and then the fiber optic cables are moved to line up perfectly with the various galaxies that are in the field of view. That allows them to separate the light just coming from that galaxy. They can then take redshift information, spectroscopic information that allows them to learn the chemical composition of that galaxy. Then it moves to another spot, takes a 20-second exposure, collects light on a bunch of other galaxies, and then moves on and moves on. And so over the course of 5 years, they have mapped out 14,000 square degrees of the sky. And just for comparison, the entire sky is about 41,000 square degrees. So that's a big chunk of the sky. They've captured images of 47 million galaxies and quasars. And again, they were lining up these fiber optic cables with their instrument to be able to get individual information on each one of these objects. And this gives this gigantic 3D map of the cosmos. And this will allow astronomers to analyze and see what was the clumping of galaxy clusters like early on in the universe compared to what it is today. And that will hopefully be able to measure the effect of dark energy over time. Will it confirm this newly discovered, evolving dark energy discovery that was made with DES, the Dark Energy Survey? And so this is great to get this second opinion on the evolutionary history of the universe. What is the effect that dark energy is having? Now, the survey is just done. And so we haven't gotten to the point where astronomers have analyzed the survey and come to any kind of conclusions. So that'll be next. And of course, this is just the second of these giant surveys that have come out. We're still waiting for Vera Rubin. Nancy Grace Roman is going to be launching next year, waiting on the Euclid mission. So whatever dark energy is, it is going to be measured very, very well in the next coming years. And of course, the telescope is still working fine. It's a ground-based telescope, so it's not going to run out of propellant. And so now it's going to continue on, and they estimate that eventually its full survey will be about 17,000 square degrees. It's believed that there is a supermassive black hole at the heart of almost every single galaxy in the universe. And if you look at the kind of traditional idea for how you get supermassive black holes, you had to start with stellar mass black holes. The first generations of stars lived and died, became black holes. The black holes found each other, merged, became larger. Those merged black holes merged with each other, and eventually you got into the millions and even billions of times the mass of the sun at the centers of these galaxies. And that means that when we look out into the universe, we should see these black holes coming together, almost ready to merge. Of course, it's really difficult to know when you're looking at one supermassive black hole or two supermassive black holes orbiting around each other, almost ready to merge. But that's what astronomers think they've found. So there's a very famous galaxy called Markarian 501. It's located about 450 million light years away, and it's known to have very powerful jets coming out of the center of this galaxy. And so astronomers scanned these jets for 23 years, just pulling apart all of the subtle variations coming out of the radio signals coming from the center of this galaxy. And what they found is there's not one jet, but there's actually two jets, and the two jets are orbiting around each other. And what that means is that in fact, there appear to be two supermassive black holes at the heart of this one galaxy. It appears that the lighter black hole takes about 121 days to orbit around the more massive black hole. And they're probably separated by between 250 and 540 astronomical units, but they are bleeding off their momentum and are spiraling in towards each other. And it's estimated that they will merge in about 100 years. Of course, yes, they're 450 million light years away, which means it actually happened 450 million years ago, but we should detect that merger 100 years from now. Of course, we couldn't do that with our current crop of telescopes. It's going to take next generation space telescopes like LISA, the Laser Interferometer Space Antenna, to be able to detect these mergers of supermassive black holes. So hopefully LISA will be operational by then, or some follow-on mission will be able to detect the mergers of those supermassive black holes that far away. We've got a story about this from Mark Thompson. Now, all eyes have been on SpaceX with their Falcon rockets, with Starship, but Blue Origin is catching up quickly. First, let's talk about their rockets. And we finally saw a test flight of the Blue Origin New Glenn rocket, and their first stage booster returned safely at the end of that mission. That was for NASA's Escapades satellite mission. And now Blue Origin is testing that booster. They swapped out the engine, so it has new engines, but it's still the booster that did the flight that put Escapade into space. And so if all goes well, this booster could be used for a second time for the upcoming Bluebird 7 launch, which could be as early as April 19th. Even though they did swap out the engines, they're planning on using those pre-flown engines on another future launch. So now, hopefully, Blue Origin is getting into this booster reusability game as well. And this is a fairly heavy lift rocket, and so it'll be interesting to see if Blue Origin is able to increase the cadence of this, bring more customers on board, develop more of these rockets, and actually start to really, truly get into the heavy lift game. But Blue Origin is also trying to get into the lunar exploration game. They're working on their own lunar lander technology, but they're also working on just like general technology for lunar exploration. And one of these ideas that we've talked about is called Blue Alchemist. And this is a sort of all-in-one lunar factory, something that would be able to scoop up regolith from the surface of the moon and then produce a bunch of byproducts. And this is something that NASA has been funding, and they recently passed a technical analysis from NASA, allowing them to move to their next stage. And hopefully by the end of 2026, we're going to see a demonstration of this technology. They will scoop in regolith, use solar energy, and they'll be able to produce air that astronauts can breathe, rocket fuel, glass, silicon, aluminum, iron, magnesium, and then even solidified bricks for construction materials, like say if they want to build roads or landing pads or buildings. And you can imagine even more complicated jobs like building solar cells. And yet all of the raw material for solar cells is available on the moon. And of course, you know, the end game for this is that a Blue Alchemist will build a copy of itself and then another one. That's going to turn into like some video games I've played, I think. The sun and Jupiter are made of the same stuff, mostly hydrogen and helium. And yet obviously they are very different. The sun is a mass of incandescent gas, and I believe Jupiter is where boys go to get stupider. Anyway, and it all comes down to mass. The sun is 99.7% the mass of the solar system, and then the rest is the planets, mostly Jupiter. But the way stars and planets form is very different. Stars form out of the protostellar nebula. They kind of accrete all of this material. It builds up into this dense region, and then the star ignites fusion in its core. Planets form from the accretion of small material. Essentially, you get dust sticking together, that turns into pebbles, pebbles turn into rocks, and eventually you get the planets as we see them in the solar system today. And so when we talk about adding mass to gas giants, like say Jupiter, if you added 77 more Jupiters to Jupiter, you would get the smallest possible red dwarf star. With much less mass than that, about half that, you would get a brown dwarf star, something that is still capable of fusing deuterium in its core, just not able to fuse hydrogen in its core. And so when is it a star and when is it a planet? Well, now astronomers think they found an object that is right on the line. It's designated 29 Cygni b, and it's 15 times as massive as Jupiter. And it orbits around an A-type star. And so you've got this object that is essentially a brown dwarf right on the edge of fusing deuterium in its core. But how did it form? When astronomers look at the composition, it is a gas giant. and yet they detect chemical composition that shows that it probably formed inside the star's protoplanetary disk. And so it had a formation that was much more like a planet, even though it behaves much more like a brown dwarf star on its way to being a full star. And so it's interesting to sort of figure out what is the formation methodology of the two kinds of objects. Is it just mass, or is there like a different lineage on how these objects are formed? Got a story about this from Evan Goff. Every week we do a vote on our channel where you tell us what you thought was the best space news story of the week. And we knew that you were all just going to pick Artemis II. And so we swerved and we gave you 2 votes last week. One was all the not Artemis stories, and you got to pick from that. And the winner last week was the new dark matter experiment has finally reached its cold temperature and it's about to start searching for dark matter. But then we had you vote on what you thought was the best photograph from the Artemis II mission. And the winner was the Earth set image. So thank you everyone who voted for both of the polls that we put up last week. I think that was very clever of Anton to break this one up so we could get a better analysis of the events of the week. We're going to put the vote for this week's episode into the post tab here on the channel. So if you enjoy this kind of thing, go into the post tab, find this episode and vote. But if you're just subscribed, click on the notifications bell, and if you just train the algorithm to show you the votes, they should show up every single week. Venus is a very mysterious planet. If you look at it in a small telescope, you will just see this orangish ball. In fact, the best telescopes on Earth don't show anything but an orangish ball. And that is because there is a very thick layer of clouds and haze in the atmosphere of Venus. It wasn't until the Soviet landers reached the surface in the 1980s that we finally saw our first picture of the surface of Venus. It was not a jungle world, as the science fiction authors had proposed. It is a brutal oven-like hellscape. We also have radar images that were taken by NASA's Magellan spacecraft in the late 80s and in the 90s. But that just shows us at very rough resolution the surface of Venus. But there is this thin haze that surrounds the entire planet. And scientists have had a really hard time explaining where this haze comes from. It's just below the cloud deck where you have these clouds of sulfuric acid. Just underneath that, there's this thin layer of haze. And now scientists think they found the answer. It's caused by cosmic dust. So what happens is micrometeorites are raining down into the atmosphere of Venus in the same way that it's happening everywhere around the solar system. These micrometeorites break apart and they interact chemically with the clouds of sulfuric acid. And then these act as the seeds for the formation of haze just below this cloud deck. And so now we've got an explanation for where some of the haze in the atmosphere of Venus came from. Got a story about this from Mark Thompson. The moon is actually a really difficult place to explore if you want to go for longer than about 14 days. That's because it takes about 29 days to go through a full day-night cycle on the moon. And so if you build a rover on the moon, it's got to be able to survive 14 days in sunlight, which is fine, right? You got lots of energy, warm temperatures, your rover can get a lot of work done, but then you got to survive over 14 days in the darkness and the cold, which kills batteries. And we have reported many times where spacecraft have landed on the surface of the moon and we're waiting to find out if they will recover after the lunar night. The solution to this problem is to use a radioisotope thermoelectric generator, which is a decaying chunk of plutonium-238, which can then produce not only heat to keep the rover warm, but also electricity to allow it to power its instruments and continue roving. And this is the kind of power system that will probably be needed to go into the permanently shadowed craters on the moon. The problem is that plutonium-238 is very expensive. It's essentially the same kind of material that is used to make nuclear weapons. It's used for nuclear reactors. It is a controlled substance. And so researchers are proposing another isotope known as americium-241. And this is produced as a byproduct of nuclear reactors, and so should be easier to use for space missions. And so at a recent conference, engineers were talking about how they could use this americium-241 as the power system for a rover on the moon that could go into the permanently shadowed craters and survive the lunar night. Got a story about this from Matt Williams. And I actually have an interview that I did with one of the people behind the company that is proposing this. And we talk about not only americium, plutonium, but other isotopes that could power spacecraft for varying amounts of energy and varying amounts of time. So check that out. Supernova are exciting whenever they happen. You know, these are some of the most powerful explosions in the universe. But even how bright they are, we can't detect supernova more than a couple of billion light years away. And obviously it would be very useful to know, were the supernova in the very early universe different from the supernova that we see today? How have the chemical abundances of the universe changed, and what has that done to supernovae? And so astronomers recently were able to see a supernova that went off over 9 billion years ago thanks to a gravitational lens. This is, of course, a natural telescope lens. So at about 5 billion light years away, there was an elliptical galaxy that was directly lined up between us and this more distant galaxy that contained the supernova. And then the light from the supernova went around this foreground galaxy, and it was magnified between 100 and 250 times. Imagine you took the telescope and then increased its size by 100 or 250 times to be able to image this supernova. That's what it would have taken to do it directly. Not only that, but astronomers were able to watch multiple versions of this supernova appear around this foreground, because different parts of the light will take different journeys. And so you'll have the supernova appear at separate times. And one of the things that's really great about this story is that this discovery was made using the Zwickett Transit Facility, which is kind of a precursor to the Vera Rubin Observatory. And so these are the kinds of objects that Vera Rubin will find on a very regular basis. I've got a story about this from Mark Thompson. I hope you're enjoying this week's episode of Space Bites, but you probably had to suffer through some ads at the beginning of this episode. There might be an ad at the end of this episode. Now, we don't put any ads in the middle, but we can't control the ads that you're going to see. But there is a place where you can watch this exact same episode with no ads at all. And that is, of course, over on Patreon. And to encourage you to go and watch this episode on Patreon, remember, it's completely free. There's no ads. You don't have to pay. You don't have to donate. You can watch it anonymously. But to encourage you to watch it over there, we're going to put one additional story into this week's episode of Space Bites. And this week's bonus story is how a team of student astronomers found one of the oldest stars in the universe. I'll put a link down in the show notes. I'm going to give you a better sense of our reporting on Universe Today, but first, I'd like to thank our patrons. Thanks to Abe Kingston, Andrea Pedretti, Bear Lake Roofing, Brian Bodie, Caroline, Chuck Hawkins, Commander Bielek, Darkfinger, David Gilton, David Matz, Evan Pro, James Clark, Janice Smith, Jeremy Mattern, Jim Burke, Jordan Young, Josh Schultz, Marcel Sutz, Michael Purcell, Nordspace, OneStepForAnimals.org. Follow my nephew at VBrick6994, Ren Kaidu, Richard Williams, Sean Sargent, Team Filer Monthly, Team 49, Telescopes Canada, Vlad Shiplin, Wolfgang Klotz, and Zelda Borg Galactic Defender, who support us at the Master of the Universe level, and all our patrons. All your support means the universe to us. So I always talk in my episodes about how we are just reporting on a fraction of the stories that we're covering on Universe Today. And I want to sort of just give you a more detailed sense of how many stories that we're covering on Universe Today. Like just this week, we've got a guide to the April Lyrid meteor shower, which peaks on the 20th, 21st of April. Should get 18 to 20 meteors per hour. We've got a 4-part series from Dr. Paul Sutter about astronomers understanding neutrinos and trying to figure out if they are their own antiparticle. And then a second series from Dr. Paul Sutter about the discovery of Cherenkov radiation. We've got a story about 4-legged rovers that could explore really complicated regions on the surface of Mars, go into lava tubes, things like that. Think about these, these robotic dogs, but with science experiments on them. We've got another story about supermassive black holes that are set to merge. We've got an analysis of whether it's the big flagship missions that give us the most science, or whether it's the $100 million, very specific focused missions that give us more science. So researchers went back for 30 years and looked at the number of high citation papers to figure out which one was more effective. We've got an upcoming experiment that's going to test the flammability on the surface of the moon. A story about how the magnetism in the sun could be fossilized, how features inside the sun could maintain their magnetism from the birth of the sun all the way through to when it becomes a white dwarf. Story about a submillimeter telescope that has just become operational in Atacama, Chile. How astronomers are looking at craters on the surface of the moon to peel back the history of impacts at the south pole of the moon. How an asteroid impact that happened about 900,000 years ago might have been much more significant than we thought and put the Earth into a nuclear winter for quite a while. How features in Saturn's magnetic field are not where they should be compared to the Earth and other planets in the solar system. How a Chinese rover on the far side of the moon listened for signals from aliens in a place that is essentially the quietest place in the solar system. And then there's going to be a bunch of stories that we will work on Friday morning, just in time for me to be able to send out my newsletter. So that's just that's a more complete version of the kinds of stories that we're covering on Universe Today. And that's why I really recommend you subscribe to my newsletter. Doesn't that sound cool? A Chinese lander listening for signals from aliens on the far side of the moon, four-legged rover that could crawl into lava tubes on the moon. Yeah. You want to subscribe to the newsletter, universetoday.com/newsletter. All right. We'll see you next week.